Thank you. Last class, we discussed few aspects up to session block 2 we discussed, and now we'll move forward towards unit 5. We'll move forward towards unit 5. Here, in unit 5 is consist of statistical tool, where we stopped exactly this. What is meant by statistical tools used in TQL? In that, we use flowcharts and check sheets, histograms, hetero diagrams, cause and effect diagrams, control chart, scatter diagram, and this might be helpful for this TQM statistical tools. First, we'll see what is meant by flowchart. Why we need to use the statistical tool? In order to take any quality comes under metrics. We need to measure the quality by metrics. So here we'll see the employee identify and correct the quality problems need to proper training. They need to understand how assess the quality using variety quality control tools and interpret the finding and how to correct the problems in this. Okay, and so statistical process control is also information of the basis decision and action. So here we'll give some kind of information. How many employees trained? What is the productivity? It's a quality metric. How many number of employees trained and the productivity of the employees outcome will comes under this quality matrix. 1 minute. Okay. Correct. So here we use flowcharts. What do you mean by flowchart? I think you people might be studied flowchart in schooling days. What is meant by flowchart? A flowchart is a consist of systematic direction of any systematic direction. Okay, so flowchart is a process map. These pictorial represent process of shows the sequence steps performed. So here we'll see in programming also start to end. So where to start, where to end. Is there any loops are there? We are going to represent the loops. So here flowchart is a list of order of activities in project or process their interdependency. So in express detailed process knowledge, to express the knowledge criterion symbols used, while diamond indicate the decision. Diamond is nothing but decision. Okay, being end of the process, and so we'll have end of the process, and boxes indicating the action item, while diamond indicating the decision check or checkpoint. The flow chart can be used to identify the steps effectively affecting the quality and a potential control point. Another effective use of the flow chart should be map the ideal process, actual process to identify their difference and target improvement. Flow chart is often the first step in business process re-engineering. Now, we can see the flow chart. We'll see here. Now, we can see this is the start. This is start. I can cannot be working. So lamp does not work. Lamp plug-in, no. Lamp plug lamp. So bulb burned, yes, replace the prompt. And or repair the lamp. What happened? The action. So you can see uh, production is raw material is having problem. Check the quality like that. So we can use n number of questions. So in that, in flowchart, there are two types: one starting point, then directions, yes or no. If it is yes, again it's going to another loop. If it is no, it joined in another loop. So sometimes might be conjoined with the two or three activities. So it's called flowchart. Mostly you people might study it in lower sections. So checklist. Okay. So checklist. So what is meant by checklist? Where you have to see the checklist. So checklist is the one type of document. So whether how many items are there by this, we are going to count. So we'll go into this. These tool aid to data collection. Designing to collect the data must ask basic questions such as the questions we are trying to answer: what types of data will need to collect, where can we find the data, who can provide the data, all those things. Now checklist data form facilitate the interpretation of the data. We are going to interpret the data. And types of attribute availability, and attributes data obtained counting from some type of visual inspection. Okay, number of invoice, container errors, characteristics such as distance, weight, volume, common examples. Now here we'll talk about checklist for attribute data, airline compliant. Airline compliant. In generally, airline compliance, what are the complaints we are going to? Loss of luggage, baggage delay, missed connection, poor cabin service, and ticketing. So how many complaints are arises? Daily basis, weekly basis, monthly basis. So all those things, even hourly basis also we are considering. We'll club together. First, we'll take hourly basis report. Same thing checklist. You people might be watched in no restrooms. If you go to any kind of corporate office or any kind of malls or hospitals. Okay, so they'll see in the checklist. So particular item, who clean, time, yes or no. So this is a matrix to measure the quality. We need to ask. So here also we are going to see wrong order. Another thing, wrong orders, reworked orders, late deliveries, shopping damage, late payments. Okay, so these are the things. So like Monday, Tuesday, no, earlier it's week, it's daily checklist. So this is checklist. It's kind of numerical data which helps for representing the data. Histograms. It's very important thing. Interesting. Histograms. What is meant by histogram? First thing, histogram is a bar chart. Earlier we are into numeric. So first thing, flow chart is nothing but map, route map, and here metrics counting. So histogram that is converted into chart format. Histogram is a bar chart showing distribution of variables, question, or characteristics. For example, live histogram would be line up to height of the group student enrolled in course. So here the example of histogram, age versus frequency. The normal collected in course. Normally one individual would tallest one should be tall customer, so shortest. The cluster of the individual group, cluster. What is maybe cluster? Group of people, individual group around the average height. So here, manufacturing histogram can rapidly identify the nature of quality problems processed by shape of the distribution as well as width of the distribution. So here, shape of the distribution as well as width of the distribution. It formally established process capacity. It can also help compare two or more distribution. So here, the variation in the process always exists. Generally, displayed pattern can be captured histogram. A histogram graphically representation of variation in set of data. It shows frequency number of observation, particular value within specific group below histogram or drawn age versus individual. So it's all about uh, Pareto diagram. Pareto diagram, no, you can see it's combination of chart and line kind of thing. Pareto diagram is prioritizing the type of source of problem. Pareto analysis separate the vital vital few from trivital many, provides helps in selecting direction improvement. So here, now you can see here number of occurrences in 2016 failures in Pareto diagram failures in 2016. So failure type. So there are different types of failures are there. Failures are there. Then here number of occurrences we are going to measure like this. Dimensional diversification is cause. Correction is one called. Short circuit is another called. Tool market is another. Wrong number is called. Wrong part is called. Then transportation damage is another thing. Missing comfort is there. Surface. So all together, it's counting how many percentage. So it's having 100%. So put together. So Pareto analysis is a technique used for identify the quality problem based on their degree of importance. So here, the logic, this analysis is only few quality problem are important, whereas many others is not critical. This technique was named after Wilfredo Pareto, 19th century Italian economist who determined only a small percentage of people controlled most of wealth. This concept has often been called 80-20 rule. We have 80-20 rule, 80-20 rule, and has been extended many of areas. The inequality matrix, the logic behind the Pareto's principle is that most quality problems a result of few causes. A trick identify the cause. One way to use Pareto analysis to develop a chart ranked caused poor quality, decreasing orders. So decreasing orders based on the percentage of defects in each class. No, already we have seen the chart. Okay, cost. For example, a tally can be made number of defects that result from the different causes, such as operator error. We discussed operator error, defective parts, and inaccurate machine collaboration, percentage of defects, and can be computed from the tally and placed in chart. So generally tend to find the few causes accounted the most defects. No causes, you see the causes. Dimensional diversification, correlations. So this is the Pareto diagram. Next, we'll have cause and effect damage. The cause and effect damage. Now, so here, root cause and effect. So here, we are going to identify in these diagrams, what are the cause is affecting the problem. Now, here, we are going to directly diagram. You see, flat tire. This is the car. then loss of control of the car. So this is the effect. This is the effect. Lost control of car. Flat tire, whatever, nail, rock, and blow out glass. So this is the problem. Next, there are certain problems are there related to mechanical failure, fluid loss, brake failure, work pads, broken tie rod, and then stuck accelerator. These are the mechanical related causes. Then slippy road. So these two related to car. This is related to road where you are driving. So road is like oily, ice, whether it's raining or it's snow. Okay, it causes for damage of accident related to car control. Then manually we did mistake. We means driving. Who drives the car? Driver mistakes. What are the mistakes they did? Recklessness. Sometimes they may be drowsy or sleepy or poor reflex, like chemically impaired or poor training of the driver. So these are the causes which may affected for loss of control, even overspeed also. So you can write what exact cause which may affect the driving. So cause and effect diagram. So we need to maintain in pictorial way. So cause and effect diagrams are charts identify the potential causes, particularly a quality problem. They often called fishbone diagram. So you can see this. This is diagram like fish. Will already are also known as fishbone diagram because they look like fish. General cause and effect diagram shows in below. Already we discussed. So the head of the fish is the quality problem. Here quality problem is loss of control car. So here head said positive cause of the problem. This cause could be related to mechanics, workers, measurements, suppliers, material, and bone that address the specific issues related to each cause. For example, problem of mechanic could be due to need of adjustment, old equipment, and tooling problem. Similarly, diagrams are problem solving tool. Commonly we can easily identify where exact problem is happening. So fishbone diagram. Okay, so training, poor supervision, figure cause and effect diagrams are problem solving commonly used to quality control team. Specific causes problem can be explored through brainstorming. So brainstorming sections also there. Brainstorming, the development of a cause and effect diagram requires the team of think, thought all possible cause of poor quality. So next, control chart. Somebody is drawing. Any question? Hello. I think Pavani.
I'm sorry, sir. It has been on.
Oh, okay. If you have any question, please ask the question now.
Sure, sir. I was setting the voice. I'm unable to hear. That's the reason. I just
Now it's audible. Now it's
connect.
audible.
Yes, ma'am. Yes, sir. It is audible.
Okay, okay, Pavani.
Yeah.
Fine. So, thank you. Yeah. So here cause and effect diagram like fishbone. So generally they can easily identify where the root cause of the problem has happened. So then group of people they'll involve and discuss related to problems. Okay. Right. Next, control chart. So control chart. So SQC will call control chart SQC. What is meant by SQC? SQC, statistical quality control. SQC is nothing but statistical quality control. And uh, you know uh, were first proposed Walter in the year of 1924. So here in this method, identify the special causes, variation in singling the need to correlated action when appropriate special cause you know special need to identify appropriate when special causes are present. In the process set out of control. So SQCs provide technique for improving quality in productivity. So it's a chart display state of control of a process, time measuring horizontal axis. Okay, horizontal time measuring horizontal axis and above variable of vertical axis. And vertical axis is like uh, you know a centralized process said to be out of control. A control charts are very important quality control tool. We'll study the use of control charts in length of next step. We'll study next step. Now you can see, I'll explain this control chart. Example of control chart. You can see here, uh, so number of occurrences. What happened? Number of occurrences. So lower CL. Okay, what is meant by CL? Control limit. So control limit will fix 20. Lower CL. LCL means lower CL. Okay. UCL means upper control limit. So upper control limit. Now here sample number. So it's 1, 2, 3, 4, 5. So we need to check number of occurrences. So what happened if it is supply number is to statistically represent. So control here control you may going with subgroup average. So again you'll see middle CL control level and control limit, upper control limit, lower control limit. So they'll have count is number is there. It's going to be vary. By this, we came to know that so whether which element. So how many subgroups it's having high and low. So we are going to interpret. We'll take some proper action against this. Next statistical tool here scatter diagram. Scatter diagram. Now you can see scatter diagram is to identify like mapping percentage of months with university education and mean BMI. And so here you can see the quality characteristics and process input. So once it is going to be mapped, 0, it's going to be mapped. Group of data is there. Okay. Next session, tomorrow, I'm going to show the sample data of this and how it's going to be added by using Excel. Tomorrow, I'm going to give that scatter, how we can generate the scatter plant by using Excel. Next session. So this is how scatter diagrams also help to relate the data. You can see scatter diagrams illustrate the relationship between variables. What is mean by variable? Which may be varying nature. The relationship. So what is the relationship? It's positive relationship, negative relationship, no relationship, strong relationship, strongly relationship, positively relationship. Okay, no negative relationship or no relationship, like that. So a general trend of the point going up and right the indicating variables corresponding incurred in others. In the field of trend, down right increases. So this is how histograms. So you can sorry, scatter plant, not histograms. Histograms already we studied. Next. So this is how we are having scatter plot, control charts, and cause and effects, and paired diagrams, and this histograms. Okay, so this is very simple unit. You don't have any formula to remember, but you have to remember how practically it's going to be happen. So in Excel, there is a provision. You have the data and select the data, and you will have the charts section. Okay, insert charts where you can find histogram. Okay, where we find histogram and Pareto diagram, and you will find you no fishbone is not there. Okay, control charts and scatter diagrams. So this is how this unit like okay, statistical tool with respect to diagram. Then statistics as a basic of quality control. Here in this unit we'll have types of statistics, variation of basic quality control, types of variation, statistical quality control, statistical problem solving, accepting sample. So these are the components are there in this unit. So I think we may study tomorrow in detail. Okay, so this one unit, no, I'm going to cover this today's class, and tomorrow we'll have the problems are there, like mean. You can see the mean, median, range. Okay, so you have to remember some formulas, basic formulas, and how it going to be calculated. No, I'm going to give the few tips to you, like how you can remember. It's a basic kind of statistical tools we are going to study in this chapter. Okay, be ready for tomorrow. So if you have time, and take pen and paper and practice it, or else I'm going to provide how to no remember the statistical tools for this paper is concerned. So with this,
Sir, I
please,
just have a query.
please.
I just wanted tomorrow if you can please show us the problem solving. Why? Because when we on the exams time, I started doing, but it's becoming a very difficult. I'm working on it. But if you show us as an example one problem, so that we'll be working on a number of problems, so that will be making us easy. Just
Sure,
it's
sure.
a request.
That's what. No. That's what I'm stating. That take pen and paper with you.
Yeah, yeah.
Okay. Today you are asking the question. Before that also, I said that you take pen and paper. And tomorrow, if time permits, means now I joined with my mobile. So tomorrow, time permits means how you can draw, scatter plots by using
Yeah.
Excel. Excel. I'm going to demonstrate for you by
Okay.
using like technological advancement. So I'm going to demonstrate for you. So tomorrow, basic statistics, I'm going to show it to you how to solve the problems.
Okay,
Okay.
sir.
If
We'll
you,
be with the pen
uh,
and paper. Will be there.
okay, because it's if it is offline means I am going to write on board and I am going to display. If it is online, so what I'll do, I'll prepare one document for you, and I'll
Yeah.
share it step by step. Problems, basics problems for you. I'm
Okay.
showing, displaying the huh?
Yeah.
Okay,
Okay, sir. Yeah.
but right. Okay, tomorrow we'll see. Yeah? Okay, thank you,
Okay, sir. Thank you very much, sir.
thank you.